a Swift adventure moving from Python to Swift. So as many of you know, I work for Walt Disney Animation Studios in Burbank, California. And most of our films use CG animation. And the tools and the processes for CG animation have really huge overlap with the visual effects industry. So we use tools like Maya and Houdini and Nuke. And one of the common threads between those tools is they use the same scripting language for extension and automation, and that language is Python. So it's very hard to avoid the use of Python at Disney Animation. It's used all throughout our pipeline. TDs use it all the time. There are internal tools written in Python, just tons of Python. You can't avoid it. So back in 2008, my manager at the time, we were having an annual performance review, setting goals for the year, or whatever, that sort of thing. And he said to me that I needed to learn Python. I didn't really know it at the time, but he said, you know, since the studio relies upon it, it would be really good if you got good at Python too. Well, I don't learn computer languages in a vacuum. I can't, you know, go to an online course or look at a book or whatever and learn a computer language. My brain just doesn't work that way. I tried to learn C several times that way. It never worked. C++, right out, could not wrap my head around that at all. I found what I needed was an actual problem to solve, an actual project to build. And then that would kind of force me to do the work, to, you know, muscle through the tough places and learn how to actually use the language. So at that same time, when I'd been asked to learn Python, the Mac management software that we were using at the time, which is RadMind, it was kind of no longer a good fit for what we were doing. And so I knew that we needed to move to something else. And the budget year is what it was, and that there was no way we were going to be buying anything for several months, probably close to 9 months before there would actually be budget to buy anything. So I needed to learn Python, I needed a project, I needed to replace our Mac software management system, so I thought, why don't I see if I can write something in Python to manage software on our Macs? And that was the beginning of Munki in late 2008. So I first started work on the command line tools, but I knew eventually I was going to have some sort of GUI that the user would see that would show them what software is available, you know, what was happening. There still need to be some sort of user interface. And I had never written a real Mac application using Objective-C or Cocoa, any of those kind of things. And so I was looking for a shortcut. You know, how can I get something up in front of the users quickly using something I already know? And there was something I did already know. It was called AppleScript. And Apple had this tool called AppleScript Studio, which has a really unfortunate three-letter acronym. But with AppleScript Studio, you could write the code for the application in AppleScript, and you could still use Interface Builder to design the menus and the graphics that the user would see. And I cheated there as well, but because what I was doing with managing the software, I was patternering. Yeah. I was making the tools ape the experience of Apple's software update at the command line, so I figured I would do that as well at the GUI. So I simply stole the look of Apple's software update application at the time and wrote a very similar looking GUI in AppleScript Studio. So it was basically a glorified dialogue. You know, you just basically saw a list of things that were pending to be updated. You could get a little information on it, and you could choose to either do the update now or defer it till later. There was also a window that showed the progress of an installation, so you know, a user would know something was happening while those installs were happening. So this was spring 2009 that these became available. A few months later, in the fall, Apple released 10.6 Snow Leopard, and they deprecated AppleScript Studio. Gone. Well, it was still there, but it was mortally wounded. So I knew I couldn't stay with that for a long time. Plus, I'd found some issues with using AppleScript for this work. There was just some oddities. There was some interface that didn't look professional. It didn't look native. It was just kind of clunky. So I knew that wasn't good for a long-term solution, and that I was going to have to move on to something else for these GUI apps. Well, by that time, I was comfortable enough with Python, I thought, maybe I can use Python to write these GUI apps. But actually, what I needed to use was Python plus PyObjC. PyObjC is a set of libraries that allow Python to call Apple's Cocoa and Foundation frameworks. So for me, at the time, it was a perfect fit. I knew Python. I could kind of read Objective-C, but I was not confident enough in my ability to write it. And back then, Objective-C was really easy to write badly. It was very easy to write Objective-C that crashed and did all sorts of horrible things. It's better now, but then you had to be a pretty good programmer to write good Objective-C. I was not one. So Python was more forgiving, but yet I could still use it to call some of Apple's frameworks. So great. I could still use Xcode to lay out the interface. I could write the code in Python. I could tie it all together. And a few months later, I had a version of the GUI apps that was in PyObjC. And we kept cramming more features into it. We added optional installs, which, given the original interface, was a really terrible fit. It was just this list, and you had to search, and it just looked like ASS. But it got the job done. Shortly after that, Apple released OS X Lion, and now I had a new interface I could borrow ideas from. So in October 2014, we released Munki 2, and it replaced the Managed Software Update application with a new Managed Software Center application, but it was still written in PyObjC. So in my opinion, this really demonstrates how powerful PyObjC really is. You can write a relatively modern, professional-looking Mac application, mostly in Python. So if we can do that, if PyObjC works just fine, why not just stick with it forever? Well, there's a lot of reasons why you might not want to. That last one up there is probably one of the more important ones. Apple's Python that they ship is Python 2. Python 2 is the end of life, coming up very, very soon now. Last week, it seemed very clear that Apple's going to pull Python 2 completely from the OS at some point in the future. But there's other reasons. It's sometimes really hard to access some of the newer frameworks from Apple in PyObjC. The main view in the Managed Software Center main window is a web view. And I was using the original WebKit web view, which turned out to be deprecated in 10.10. And Apple recommended that you replace it with something called WK WebView. But it looked really hard to work with in Python, in PyObjC. It might have been possible, but it just looked like it was going to be tricky. And when you're trying to figure out a problem, a lot of times you want to go out on the web and look for code examples. And I mean, there's another ding against PyObjC. There's not a lot of good code examples out there. You're trying to solve a problem on a Mac app, you're going to find examples for Objective-C. You're going to find a lot of examples for Swift these days. PyObjC, not so much. And another huge reason, Xcode. Xcode is a terrible development environment for Python. You can paste Python code into the Xcode text editor, and it will change all the indentations. And if you're familiar with Python at all, you know that's a bad thing. So you have to go back and fix the indentations. It doesn't come with Cocoa Python templates, so the actual starting templates that you use, you have to get those from somewhere else. It doesn't do code completion. It doesn't do dynamic syntax checking as you're typing in the code. There's no integrated debugger. You can't debug your Python right from inside of Xcode. And so none of those things are showstoppers. I mean, I was able to write both versions of these applications in Xcode with PyObjC, but you're throwing away a lot of the help that Xcode can give you if you choose to write your apps in PyObjC. Xcode is way more helpful if you're using Objective-C or Swift. So the final reason I would say is I simply wanted to learn Swift. So I learned Python by writing the original Munki tools, and it occurred to me that maybe it would be fun to try to write new versions of Managed Software Center and the Munki Status app in Swift, and that this would be a great opportunity for me to finally learn how to use Swift. I'd been paying attention to it since it had been released in, 2014, but I just really hadn't found a project that would force me to actually sit down and do the work. So let's take a look at an example of PyObjC code and the equivalent Swift code. Right here we've got a Python function, and it reads some preference values from Munki's preferences. And it falls back to some internal default values if the preferences are not defined. On the right is some equivalent Swift code. It really doesn't look that different at first glance. The big differences are Swift uses curly brackets instead of indentation to delimit code blocks. It uses the let keyword to define constants, which are values that won't change, and the var keyword to define values that will change. Python doesn't really distinguish between those two types of variables, except by convention, but Swift is very specific about that. And Swift has type annotations for variables, constants, and functions. It requires you to declare what type of value a variable will have or a function will return. So I started the conversion to Swift by simply creating a brand new empty Cocoa app, selecting Swift as the language that I was going to be using, and then I took each module, module by module, function by function, and converted it from Python to Swift. And I did it often by just simply taking the Python code and pasting it right into Xcode. And Xcode helpfully told me this is not good Swift, right? And so then I just kept editing it and watching the warnings go away until eventually, ta-da, Swift. Now, of course, I spent a lot of time, looking at documentation on Apple's site, reading the Swift.org documentation, reading the books on Apple's iBook store, searching the web, Stack Overflow, those sorts of things. But that really was a very useful, valid way for me to do it. Xcode helped me there. Just paste the code in, look at the warnings, figure out, oh, what's it telling me I'm doing wrong here, and mangle the syntax until it got transmorgified into valid Swift syntax. Now, just because Xcode doesn't complain about the syntax anymore doesn't mean the code actually works. But that's another great thing about Swift, is you can kind of sort of treat it like a scripting language. I could take these small bits of code, a function or whatever, copy it, paste it into my text editor. I still use TextMate. I know it's been dead for a very long time, but old habits die hard. I'm sure there's people here who love Emacs because they learned it when they were young and they still like it. I'll probably be the last person on earth using TextMate. But I can paste that into a file. I can hit Command-R, and it runs. So I can test little bits of code almost as interactively and quickly as I did when they were in Python. I don't have to wait until I have an entire application that can compile in order to test it. I can test, oh, that function works, oh, this function works, great. And I can slowly converge on something bigger by testing each of those little pieces. So I started with the Munki Status app, which contains only 1,400-ish lines of Python. And I had to do a little research to remember exactly, but I looked at the Git logs, and it looked like I started work on this in May of 2018. And then a search through Slack told me that I was actually telling other people that it was mostly done, mostly functional, by May. I just said May, by June. So about a month to do that. And the completed code, only 700 lines of Swift, so obviously Swift is twice as good as Python. That's for you, Joel. The launch speeds, about the same. The Munki status is a very simple app. It launches very quickly. In both cases, it seems to display the window in under a second. The original Python app, 1,700,000 bytes, so just under 2 megabytes. Yikes. Swift version is almost 14 megabytes. And this is true with any Swift app that you write, because 11 megabytes of Swift libraries get copied into every single one of those apps' frameworks folders. It carries the entire Swift run framework with it for every single app. So kind of a minimum size of any Swift GUI app is going to be 11, 12 megabytes. Disks are big these days. Do we really care? I don't know. But it is something to be aware of. The Python version of Managed Software Center is way more complex. It has about 5 times the code of Munki status. And I started work on this one in June of 2018. I was able to borrow some code from Munki status. There's a few, utility functions that they shared, but there was a lot of unique code in Managed Software Center. It took me about three months or so. The lines of code remained about the same. It does launch much faster. The Python version, you click on it, and you see it bounce and bounce and bounce and bounce in the dock, and eventually it comes up. The Swift version, at least on this machine, click it, comes up, single bounce. So that's really nice. But again, we still have the giant size difference. So that's pretty standard. So if you want to compare and contrast the code, both versions are still up on GitHub, so you can take a look and see what I did there, if that interests you at all. Joel. But let's talk a little bit about some of the challenges that I encountered when porting the GUI apps from Python to Swift. Two of the biggest ones were me understanding and properly using Swift's optionals, which we'll get into, and properly dealing with Swift's static typing. Now, it's hard to really talk about optionals without understanding static typing, and it's really hard to talk about Swift's static typing without understanding optionals, but let's try anyway. We'll start with Swift optionals. Let's go back to Python for a second. Python is dynamically typed. A variable name can be bound to one type and then later bound to another type. So here, I assign none to foo, print it. Later, I can assign hello, which is string to foo, print it. Python has no problem with that. And this is really a very common pattern, especially in Apple's frameworks, where a variable, a function or a method might return something or it might return nil, which in Python would be none. So that sometimes you get nothing back from a function, or a empty value is another way of thinking of it, and sometimes you get a value. And in Python, you can do some simple testing to see if a variable is not none before you do something with it, so that you have a little bit of safety if something bad would happen if the variable was none. But Python's usually pretty forgiving, and even if you do pass none to a lot of the functions, it'll do something reasonable with it. Swift, completely different. It does not allow you to assign nil to regular variables at all. And it doesn't allow you to assign two different types of things to the same variable. It's called a type mismatch. But Swift does have a type that works as a wrapper for this sort of thing, and it's called an optional. Here I've written it as string with a question mark after it. The original syntax, which still works, was optional string, but string question mark is what you'll see nowadays. It's shorter. I don't know that it's easier to understand, but it's certainly easier to type. An optional can either be nil, meaning it has no value, or it can hold some other concrete type and value. In this case, we're going to say if it's not nil, it'll hold a string. So here we assign it a nil value. Because foo is nil, it doesn't print anything. But now I can... Oh, we need to go forward. Now I can also assign hello to that same value, to that same variable. Foo is now a string hello, and I can print that. But look what's been printed. And let's compare what happens in Python, Swift, Python, Swift. It's different, right? It's not just printing hello, because that's what we put in there. We put the value hello in there. But when it prints out optional hello. And that's because we still have this wrapper around this variable. It's a protective layer to protect us from the evilness of possible nils. And what we have to do is you have to unwrap that protective layer to get to the actual value inside. So one way to do that is with the exclamation point operator. That's known as the force unwrap operator. And that tells Swift, strip away the protective layer around this and give me the actual value that's inside there. So great, now I have foo has value hello. Works, great. But it can be really risky to use, because if you use the force unwrap operator on an optional that doesn't have a value in it, that's nil, your code will crash. Not nicely, you don't get a nice little warning, it just crashes. There are other ways and safer ways to unwrap optionals. This is a really common one called optional binding. And it's this special funky if-let statement that sort of optionally unwraps the value, but if foo is nil, that if-let statement becomes false, and so all that code is skipped. So you can kind of unwrap the value safely, because if there's no value there, if it's nil, that code is skipped. And there are other ways to do this. And I could probably spend the rest of this talk talking about Swift optionals. They're complex. There's lots of edge cases that will confuse and amaze and annoy you. But let's just say that optionals are important in Swift and very different from anything you'll find in Python. So let's look at the differences in how the two languages deal with variable typing. In Python, variables don't have static types. They have dynamic types. You can assign a string to a variable and then later a floating point number to that same variable, and Python won't complain. Now, time for a segue. Some people might tell you that Python has loose typing. Do not believe them. AppleScript is loosely typed. So here I set foo to a string containing the characters 1, period, 0, and then I try to divide foo by 2. What do you think will happen when I hit run? AppleScript, loosey-goosey here, it doesn't care. It says, that looks like a number, okay, fine, we'll divide it anyway. AppleScript is loosely typed. So let's try the same thing with Python. We'll assign the string 1.0 to foo, and then we'll try to divide foo by 2. No, Python isn't having it. It's telling you, I do not know how to take a string and divide it by an integer. You must be insane. So Python is strongly typed. Got it? All right, good. So where were we? We were talking about how Python variables have dynamic types. So loose type, strong type, dynamic type, strict typing. They're like it's a compass. Anyway, you can assign a value of one type to a Python variable, value of another type later. But Swift variables have static types. Once I define foo by assigning it a string, foo is now locked into being a string forever. I can't assign anything else to it but a string. And Xcode will also warn you of this type of mistake in your code. If it notices that you are reassigning or you're assigning the wrong type of value to a variable, it'll warn, it'll tell you. And you're thinking, this isn't that a big deal, just don't do that. You know, why would you ever want to assign, you know, a string to a variable and later a number to that same variable? That just seems like sloppy programming. Well, yes, you could argue that it is, but this can easily and quickly get very tricky. Let's start with Python. So here's a simplified version of that same prefs function we looked at earlier. And all this really does is it just returns the value for a given preferences key from the manage installs preferences. So I can call it, I can say, give me the value for install Apple software updates out of manage installs. And if that's true, print, we should install Apple updates. Otherwise, we should not install Apple updates. So let's run it. On my machine, at least, that value is true, so it prints, we should install Apple updates. OK. So now let's do a version of that same function in Swift. We have to make a few changes here. We have to say that we have to tell Swift that the pref name will be a string. And we tell it, this is weird. We tell it that the function can return an optional any value. So what that means is if the pref name doesn't exist, CF preferences is going to return nil. So if I ask for a preference name foo-bar-baz, it doesn't exist, so I'll get nil back. So nil's a possibility. But also,plists and Apple preferences can be numbers, booleans, strings, arrays, dictionaries, dates, NS data objects. There's probably other things it can be. That covers most of them, though. So there's a lot of different possible things I could get back when I ask for the value of a preference. And I don't know what's in there. So I have to say this function could return anything, maybe even nil. So let's run it. Doesn't work. What went wrong? Well, the error says that type any cannot be used as a Boolean test. And it points at the should install Apple updates variable. We told the Swift compiler that the pref function can return any value at all, even nil. So when we get the preference for the install Apple updates preference, Swift doesn't know what type it's going to get. It doesn't know what it's working with. We told it can be anything. So it doesn't know how to do a Boolean comparison on anything. It doesn't know what that means. So why don't we have this problem in Python? Python is dynamically typed. Python is an interpreted language, and it can determine the type language at runtime. So it doesn't need to know when you wrote the script. It needs to know right now when I'm doing the comparison, what type am I working with? And it can do that because it's an interpreted language. And Python has a much more liberal idea of Boolean comparisons. Python will accept just about any type in an if statement. I know people who use Ruby find that maddening and insane. I love it because it's just a nice shortcut. If it's a number, 0 is false, everything else is true. If it's a string, an empty string is false, everything else is true. An empty list is false, everything else is true. An empty dictionary is false, everything else is true. So it's a very common idiom to see people check for, oh, if that string is empty, they just say if that string, and if it's not empty, then the stuff inside that if block works. So that's just a nice feature of Python that doesn't translate well to Swift. So in Swift, what we actually have to do is some very fancy optional casting and optional chaining. Now, I'm not going to get into this. It's complex. But essentially what we're doing is we're telling the interpreter, get that preferences from the managed installs preferences, try to convert it to a Boolean. That's the as question mark Boolean. If that fails, just use false. So this way, I'm guaranteed to get some sort of Boolean value out of this thing. I'll either get something that makes sense, or if it can't figure out what to do with it, we'll just assume false. So I'll run it, and now it does the right thing. It converted that, whatever was in there, I think it was a Boolean, to a Boolean. It started with an any, tried to convert it to Boolean, succeeded, gives me that. So it works, but that assumes that the value inside the preferences is actually a Boolean, that it's actually what we expect. And that's not under our control. Someone else could put values in the preferences. They can assign preferences, right? I mean, look at these examples. And I've seen all of these. I can set that to a Boolean, true. I can set install Apple software updates to an integer, 1. And I can also install it to a string. And notice that it's not consistent, right? If it's a Boolean or an integer, what the Python version returns matches what the Swift version returns. But if somebody puts in a string, it doesn't. And that's because any string at all is true in Python. In fact, people have gotten really frustrated because they install Apple software updates to the string false, and then it still did it. Like, why is it doing that? Well, because false is true in Python. Duh! But this is actually the most common way I think a lot of Mac admins set this preference. They don't put any sort of type in. You know, these other ones I had, bool true, int 1, string true. They just do it naked, like that. And what that does is that sets the value to the string true. So I run it in Python, behaves the way I expect. Run it in Swift, does not behave the way I expect. And that leads to a bunch of subtle bugs. So eventually, I just wrote a function that converted values to Booleans, basically the same way Python does, because I couldn't get all the Munki admins in the entire world to do it right. It was easier just to write some code that was a little bit more liberal and behaved the way that Python did there. And type safeness, you know, the strict type, it doesn't solve everything. Compiler can't catch every type of bug. I found one where something like this caused a crash. It was trying to display a string telling me how many minutes I had until a forced logout crashed. Well, it turns out that a integer is not the same thing as an NS number, and that this particular foundation call that inserts values into a format string, if you give it a raw integer, it crashes. So I had to convert it to an NS number before giving it to that formatting function. So let's take like about 10 seconds here on a very quick demo. And let's see, yeah, excellent. So let's launch the PyObjC. Let's make sure that the dock comes up so we can see it jump up and down a lot. So let's launch the PyObjC version. Let's count. 1, 2, 3, 4, 5, 6, 7. OK, so about 7 bounces. I think, you know, somebody said, hey, you know, the Managed Software Center, the scrolling is all janky. And I didn't know what the heck they were talking about. I mean, this looked fine to me, right? It scrolls, what the heck, right? So, but let's compare now the Swift version. And let's see how long that takes to launch. Oh, 1. So a lot faster, and let's see it scroll. Is that better or worse? People told me it looks better. I don't know. Maybe it's just me. But faster. Faster's good, right? All right. Faster is always good. Now, can I switch? There we go. All right. So what does the future hold? Is it possible the rest of Munki might get ported to Swift? Let's see. Let's do a little bit of analysis here. Munki status, 1,400 lines of code, took about a month to port. Managed Software Center, over 6,000 lines of code, took about 3 months to port. Oh my God, the rest of Munki, 27,000, almost 28,000 lines of code. Okay. So we can do a graph here. And we can put Munki status here. We can put Managed Software Center here. We can draw a line of best fit. And oh my God, it's going to take well over a year. Will we even still be able to use third-party tools to manage Mac OS updates by the time in a year and a half, you know, by the time 10.16 ships? Do I want to spend a year on that bet? So I don't know. I did use porting the Munki GUI to Swift as a way to learn Swift, and there might be something new out there that would tempt me to do something, to learn something new. Last week at WWDC, Apple previewed something called SwiftUI. That looks super cool. So maybe I'll do yet another rewrite of the Munki GUI stuff and see if I can do it in SwiftUI at some point. Don't know. Thank you for listening. I ran a little bit over, but does anybody have any questions? Too fast? Too furious?
That was amazing.